Hey guys, welcome to my channel. Today I'll be explaining the GFG problem of the day. So let's mark medium, but it's very easy if you know the intuition behind it. So let's read the problem and try to approach this. So the problem is saying that you are given two strings, string 1 and string 2. Your task is to remove or insert the minimum characters from string 1 so as to transform it to string 2. So let's see how we can approach this problem. By the way, this problem this question is of recursion. So now let's see. String 1 is heap and string 2 is p. String 1 is equals to heap and string 2 is equals to p. Now we have to perform insertion and deletion operations in string 1 so as to make it equal to string 2. So how we can perform this? So we can clearly see that if we remove h and if we remove p from here, and if we add one p from here to this, so it can become p, which is equal to string 2. Now how we came to know that we are removing this and we are removing this, we are not touching this part e and a. Why? So the reason behind this is, so we can see that the e and a, it is the subsequence which is present in string 1, it is also present in string 2. So if we touch it, like if we remove this, then eventually we have to add e and a because it is present in string 2. So why to touch this in string 1? So there is no need. So what I have done is I have calculated the longest common subsequence which is present in string 1 and string 2. So we got this e and a, and here also e and a. Now except e and a, rest all elements from string 1 we can delete. Now deletion operations we get. Now we have to know that what are the insertion operations, means 2. Now we have to know that what are the insertion operations. So whatever elements we have to delete, we will be getting from string 1. Why? Because EA is the largest common subsequence which is present in string 2. Rest every other characters in string 1 is of no use, so we will be deleting. Now whatever we have to add insertion, so we will be getting from this string. Why? Because the longest common subsequence we have removed from string 2. If we avoid this, so this element we have to add in string 1 because this is the necessary element which is present in this. Why? Because EA is present in both the strings and the rest of the elements, let's say here also some elements will be, so this element and this element is not present in string 1, so we have to add. So what we'll be doing is, let's say string str1 is equals to 4, the size, and str2 is equals to 3. Now we got the longest common subsequence as 2 element. So if we minus 2, then we got the deletion part, then we have to delete the 2 elements. And if we minus 2 from here, then we got 1, means we have to insert 1 element to string 1. You all can see from above. So I hope the approach is clear and the intuition is clear why we are doing this. And I am going to dry run the how recursion is going. So just bear with me till the end and you all be clear that how it is calculating the answer. So you can see that the output is 3. So let's see the other test case also, geeks for geeks and GFGs. So it is geeks for geeks and here it is geeks. So let's see whatever deletion we have to perform and whatever insertion we have to perform. So let's see that whether any common longest common subsequence present in this and this. So we can see that geeks is present in str2 also and geeks is present in str1 also. Rest every elements we can delete from str1, and excluding the longest common subsequence from str2, rest every element we can add, but there is no elements if we exclude this longest common subsequence, so 0 we have to insert. And what we have to delete, 1 2 3 4 5 6 7 8 elements we have to remove. from str1 and 0 elements we have to add from str2. Why? Because the longest common subsequence is geeks, and except geeks no other elements present in this. So if we remove the 8 elements, we get exactly geeks equal to geeks. So this is how it is working. Now let's dry run this. Okay, so heap and p, how we are solving this? Okay, so it is heap and p. So initially our pointer is standing at this element, this both. Now the call will goes like, if the first character of both the elements matches, then we are going to increase our index. Like we got the match, so we will do 1 plus I plus 1 and j plus 1, because we got a common subsequence between those, like both the strings. Okay, I hope this is clear. And if we do not get the match, so it might be possible that in further any, like h and p is not matching, so it might be possible that h gets a match in further any calls of like string 2. Or it might be possible that if we do not match p with h, so it is possible that p can be present in further calls of string 1. So what we'll be doing is, if it does not match, then we will be increasing our, once I will increase our ith index and keep j intact, and once I'll be in like keeping I intact and doing j plus 1. Okay, I hope this is clear. I'll be giving one example of this. Like if the string is like h and p and p and h, so if our pointer is standing at h and pointer is standing at p, so if if we if we increase our pointer, like what I have told just now is, if it is not matching, then we can give, like, okay, we can increase our pointer to h. Once what I'll do, okay, now by looking into this, we can clearly see that there is a longest common subsequence present in both the part is h or p. So the size is 1, longest common subsequence is 1. Now if it doesn't match, we will give h p and p h, once keeping I intact and j move one step ahead, and once keeping hp I further and keeping j intact. So we can see that h and h matches, p and p matches. So if it is matches, then what we will be doing, 1 plus the further string, 1 plus the further string. Now this becomes out of bond, this becomes out of bond, so it will return 0, it will return 0, and finally it will return 1, and here also it will return 1. And if 2 call goes, then we have to return the maximum among 2 calls. So this is returning 1. So now let's dry run. So this call, like h and p is not matching, so we will go heap and moving the index. Okay, let me use this only, this call, and p, we have moved I plus 1 and keeping j intact. Now heap and p, we have to move j plus 1 and keep I, this only. Now e and p again not matches, so we have to do 2 calls, heap and p. We have to keep I, okay, we have to move I plus 1 and keep j here only, and here we can do heap and p. So we have to do, okay, I plus 1, so once I here only and j plus 1. Okay, now for this call it will goes like h e a p and p e a. So if it is not matching, then what we'll be doing, I plus 1 and j here only, and one call will goes like h e a p p e a. So here we have to do I plus 1, we have done I here only and j plus 1. Okay, now let's explore this path. It is on p, so again 2 calls, h e a p and p e a. So I plus 1 and j on p, again here HEAP and PEA. So again like keeping I intact and j plus 1, A and E. Now here we can see that this becomes out of bond, heap and PEA. Okay, so this is like this becomes out of bond if we move like I afterwards, and P becomes same, and if we move HEAP and PEA, so keeping I intact and moving this. So I'm not going to explore the whole path because I know that I is standing at P, I is standing at P, and here like by seeing that we are not getting P here, so simply I'll be returning like there is no match. Okay, okay, so from here it will be returning 0, and from here we can see that P and P matches, so we will be doing 1 plus, let me change the pen, we'll be doing 1 plus, if the character in string 1 and string 2 matches, then one call will go, so it gets out of bound, like P here. Okay, P already here goes out of bound, so here also we have to return 0 only. Okay, the pointer mistake. Okay, I have done a small mistake. Why? Because if we moved A to P, then P and P gets matches, so it will go, okay, this will go 1 plus HEAP and PEA. It comes to this, it comes to this, out of bond it will be returning 0, means it will further go call and it will be returning 0, so 1 plus 0 is 1, so it will return to 1. Now next call is E and this, so again two call HEAP and PEA. So A, it is not matching, first we will increase our I index, keep J here only, and second call HEAP and PEA. So then we will be doing I here only and J plus plus. Now we can see that P and E no matching, again two calls, heap and P, and here heap and P. Now P was here, if we move P I index one step ahead and keeping J here only, it gets out of bound, then it will be returning 0. Now P gets here, okay, P gets okay, I is here only and J is one step ahead. Okay, A gets matches, then what we'll be doing, we'll be calling one call, 1 plus HEAP and PEA. P I moves on P and J moves out of bond, then we'll be returning 0, and finally 1 plus 0 is 1, so it will give 1. Now from here it will give 1. So whenever we call 2, like whenever 2 call goes from a single element or the single solve function, will be returning the max of, like max of 0 and 1, so it will be returning 0, sorry 1. Now let's explore this path. So it's standing on A, so okay, so the one call will go 1 plus heap and PEA. This goes out of bound, simply 0 and returning 1 plus 0, it is 1, so it will be returning 1. Now from here it is giving 1, from here also it is giving 1, so maximum of 1 and 1, maximum of 1 and 1, it will be returning 1, and from here it is coming 1, so it will be returning 1. So let's write, it will be returning 1 and it will be returning 1. Now again two calls, so we will be returning maximum, so it will be returning 1. Now we'll be exploring this path, heap HEAP not matches I plus 1 and PEA. j intact, or we'll be writing HEAP and PEA. Now we'll be doing keeping I intact E and moving A further. So no match here, here also I don't think it matches E and A. Okay, so this somewhere goes the calls further and matches with A. This A and this A will match, and it will be returning 1 to this, 1 to this. And here also E and A doesn't matches, so here from here it will be 0. Why? Because it is pointing E and A is J is pointing here, so no E and no A, so it will be returning 0. So let's directly write that max it will be getting 1 only, and from here 1, here also 1, it will be returning 1 to this. Now let's move to this path. Let's zoom a little bit and let's explore this path. Okay, so I'll be doing a bit faster. Heap P. E is we have to first move E. Acha, E is matching, by the way. So 1 plus, move 1 index, move 1 index, then again A gets match 1 plus HEAP and PEA. So now this will move to this, and this got out of bound. So what we'll be doing? Okay, where's the pointer? 0, because J got out of bound. It will simply return 1. It gets 1. 1 plus 1, 2. So it will be returning 2. 2 here. Now this also gets explored and like come up with the answer like 0 or 1. So maximum of 2 comma 1, this will return 1, this will be returning 2. So maximum of 2 comma 1 is 2, so we will be returning 2. So now maximum of 2 comma 1 is 2. So finally the answer will become 2. We get the longest common subsequence as 2. Let's see how many elements we have to delete from str1 and insert. It is heap and it is P. We get the longest common as 2. So deletion is like except the 2 elements in str1, rest we can delete it. So 2 elements will be deleted. And what we have to insert? So except the 2 elements from str2, the rest elements we have to insert in str1. So we will be adding 1. Why? Because if we add P to this, H is already deleted, P is already deleted, we have inserted 1, it becomes PEA. So deletion plus insertion is equals to 3. So the same we are doing here. Deletion, delete is equals to str1 minus solve, insert is equals to str2 minus solve, and you can see that the answer is 3. So this is how the recursion is going. So let's write it like in conclusion. I'd like to write that if string 1 of I double equal to string 2 of j, then what we'll be doing? We do I plus plus comma j plus plus. Else we'll be doing maximum of 2 calls. Like once I'll be doing I plus 1 comma j or I comma j plus 1. So this is how we are going, and at last will be like this will go, this will like 1 call, 2 call, 3 calls. So at last we'll be returning maximum of all these, maximum of 1, 2 and 3. So let's see the code now. So I hope this is clear. So what I have done here is I have created I have called the solve function, passing 0th index of I, 0th index of j at initial stage. Both are starting from the 0th index. Now in solve function I have passed string 1, string 2, I and j. If I becomes out of bound, means str1 dot size, s1 dot size, and j becomes out of bound, s2 dot size, then we will be simply returning 0, as we are doing here. You can see here 0, we will be simply returning. Now we make 3 outputs. like output 1, output 2, output 3. If s1 I double equal to s2 of j, then we'll be doing output 1 is equals to 1 plus solve of I plus 1 and j plus 1, because the characters in both the string get match. Else we'll be doing, once we'll be doing I plus 1 and keeping j there only, and once we'll be keeping I there only and doing j plus 1. Now after all, returning maximum of op1 comma op2 comma op3. Now this code will pass the small test case, but it will not run for the bigger test case. Why? Because every time we are doing 2 calls or 1 call, so like the time complexity is in exponential, so it will fail to like pass it. So we have to memorize it. So let's see how we can memorize it. Okay, you can see that the time limit exceed. So let's memorize it. One dot size. Okay, one dot size. Nothing, I'm making a 2D DP table, comma, initially filled all with -1, passed DP here. So this is the basic like fundamental way to like apply DP. Okay, if we get DP of I j not equal to -1, return DP of I j. Now we'll be passing DP here, DP here, DP, DP, and finally we will be storing our answer in DP. P of I j is equals to this. Now I hope this will pass. So nothing much like complex I'm doing here. If I have filled initially, I have filled all the elements of DP table with -1, and while returning our answer, let's say our answer gets 0, maximum of this, then it gets stored in DP of I comma j, in I comma j, and remove -1 and the answer will be stored. And at any point of time we will not be getting -1. It means that we have previously stored our answer in DP of ij, then we will directly return our answer. The call will not go further. So let's submit it. Okay, it got submitted. So I hope the question is now clear and the intuition is also clear, and I have tried on all the like possible like way I can. So I hope you like this video. So thank you for watching and having patience.